Okay, question 5. I'm doing an improper integral. Okay, so there's going to be a problem limit. So am I going to have problems substituting in pi by 6? Well, you can try it on your calculator. No problems. If you try and substitute in naught into this, though, this has already got division by 0, and cos of 3 times naught is cos of naught, which is 1. So this will have division by 0. So there are mega problems when I put naught in. So therefore, we have got to replace that by a. Okay, so this is what we need to set up. It's worth stating at the very beginning you're going to do the limit as a tends to naught. So you're doing a nice clear statement of intent for the examiner. Right, so we have to actually be able to do the integral, okay? And we can see that if I differentiate the bottom of this, I get 3, which is nearly 2. And if I differentiate the bottom of this, I get something like sine 3 of x. So both of these are going to be log integrals. So when you do the integral, you get the first one is, you can see this is 2/3 times 1 over x, so it's 2/3 log of x. If you did differentiate the bottom of 1 minus cos 3x, okay, cos differentiates to minus sign, so on the top, you'd need to have plus 3 sine 3x. Well, I've only got sine 3x, so I need to have minus 1/3 log of the bottom 1 minus cos of 3x. Well, we don't need any of those stupid modular signs. So we are going to go, only put the modular signs in your logs if you find yourself ever taking log of a negative number. So we're going to go from a to pi by 6. Good. So put in the top limit, pi by 6. I'm going to have a bracket minus another bracket. When I put in pi by 6, I'm going to get 2/3 log of pi by 6 minus 1/3 log of 1 minus cos of 3 lots of pi by 6 is pi by 2. And then I'm going to do the same thing with a, 2/3 times log of a minus 1/3 times log of 1 minus cos of 3a. Okay, and the first one, the one with pi by 6 in, it can just be worked out. So don't mix up your a's and your pi by 6's. This is just a number. This is 2/3 log of pi by 6. Okay, and cos of pi by 2 is 0. So 1 minus 0 is 1, so this is minus 1/3 log of 1, which I do advise you to show that, but cross it out straight away because log of 1 is not. And then this bit here, okay. Now, okay, let's multiply through that by that minus. So we've got minus 2/3 log of a. So this is going to be plus 1/3 log of 1 minus cos 3a. All right, but if I try and let a run to naught now, this is going to run to, well, log a is going to run to minus infinity, so this term would run to plus infinity. Cos of 3a, well, if a was naught, this would be log of naught, which would be going towards minus infinity again. So neither of these have proper limits as a tends to naught, so I'm going to have to use some rules of logs here. Okay, well, I've got a minus 2/3 and a third, which are a bit annoying. Well, the third I can just take out as a factor. So I'm going to say this is 2/3 log of pi by 6, okay, and then I'm going to have plus 1/3 of some stuff, okay. So what's that stuff going to be? It's going to be 2 log a, so it's going to be minus 2 log a, and then it's going to be plus 1/3 log of, no, not plus 1/3, plus 1, because I've got taken out the third, haven't I? Plus 1 times 1 log of 1 minus cos of 3a. Okay, so that minus 2 is potentially a problem, but that's easy because I can turn this into log of a to the power minus 2, which is 1 over a squared. Okay, and this is just plus log of the bracket. So I can see that I've now got an addition of 2 logs. So I'm going to have a squared on the bottom and 1 minus cos 3a on the top. So it's plus 1/3 of log of, okay, so this combination of logs gives me 1 minus cos 3a on the top, and on the bottom I'm going to have a squared. Okay. If you leave that as a minus, this log's going to be the other way up. Okay, that's not a problem. Right, so now I need to consider my limits as a tends towards 0. Okay. Alright, well I'm still not completely out of the woods, okay, because obviously if I put 0 into this directly, I'm going to get 0 over 0. Okay, so I've got to do the normal trick with it. We've had it once on this paper already. I'm going to have to use series expansions again. Okay, so this is often the question where you have to use your knowledge of the special limits, x to the k times e to the minus x, or log of x times x to the k as x tends to 0. Here, they're making us do a series expansion again. So as a tends to 0, okay, well actually, let's come back to this. So we've got log of 1 minus, well, cos of 3a, series expansion. Expansion for cos x is, the formula book tells you that cos x is 1 minus x squared over 2 factorial plus x to the 4 over 4 factorial plus loads of other garbage. Okay, I only need the first couple of terms of that, okay, but I need to replace my x. I'm doing cos of 3a, so I need to replace my x by 3a. So this is 1 minus 3a squared over 2 factorial, which is 2, okay, and I think I'm bored now, so I think I'm going to put plus order of x to the 4. So the terms I'm missing, you need to do that thing where you acknowledge the terms that have been missed out, okay, but they're all x to the 4 and higher. So that will do for the top, okay, and for the bottom I don't need to do anything at all, it's still just a squared, and these ones beautifully cancel. So I've got, that's 3a squared over, that's 9 over 2 times a squared, and it's plus, so it's log of 9 over 2. Well, let's cancel my a squared, shall I? So this is going to be 9 over 2a squared, and that's a squared. Let's cancel them down. So 9 over 2 on the top, 1 on the bottom. Okay, I've got to acknowledge those missing terms on the top. Now, they were terms in x to the 4 and higher, but I've divided top and bottom by that's a 9, by the way, not an a. Okay, I've divided top and bottom by a squared. So a to the power 4, that should really say, as divided down to a squared and higher. Okay, and I can now do the limits as a tends to 0 of that. Okay, it's now acceptable to let a to run to 0 and just say this is 9 over 2 divided by 1, so the answer to this is 9 over 2. Okay, no it's not, it's got a log in front of it, so it's log of 9 over 2. So, I've just looked at this part of the expression, so therefore I need to say that my integral from 0 to pi by 6 of whatever, I'm being lazy and just not copying it all out, equals 2/3 log of pi by 6, okay, plus this limit of this, which I've now done. Okay, I haven't had the third yet, so plus 1/3 log of 9 over 2. And that's my final answer. Except it's not, because the question says, always go back to the question, give your answer as a single term. And I've got a log plus another log. Okay? Alright? Oh, that's got 1/3. So I'm going to have to do a little bit more. I'm going to do that thing of taking out the factor of 1/3 again. Okay, so I'm going to have 2 log of pi by 6. Well, that should have a 2 in front of it. Instead of that, I'm going to do log of pi by 6 squared plus log of 9 over 2. That third has gone here. So I've got a sum of 2 logs. So I've got to do this times this. So it equals 1/3 log of, well, on the top I've got a pi squared and I've got a 9. On the bottom there's going to be cancellation going on. Okay, I'm going to have oh no, I'm not. Yes, I am. I'm going to have a 9 on the top, I'm going to have a 6 on the bottom. Okay, so I am going to be able to say this is just, divide the 9 by 3, 3 pi squared. Okay, and on the bottom, I'm going to have, I should have done this properly, shouldn't I? So I could put here, let's do it properly here, 1/3, okay, log of, I've got a log plus a log, so it's log of pi squared over 36 times 9 over 2, okay, so actually it isn't just 3 that cancels, it's the whole of the 9, so I'm going to end up with 9 and 36, that's going to cancel down to a 4, and I'm going to end up with pi squared over 8 inside there, and I'm going to give that as my final answer, because that is a single term.